Now we're going to look at an example for the root test, and it's going to be fairly obvious to decide. I don't know if you can hear the dog breathing, but the dog is scared by the wind. Can you? Yeah, that's the dog. Okay. His face is right by the microphone. What was I saying? Oh, it's going to be really obvious when to use the root test, and that's when you have powers of n, and then it's not a geometric series. So let's take a look. Now for this, well, it's the same instructions as last time, except for we're going to use the root test, and that's fairly simple. All you do, you have the same conclusions, so hopefully that's not hard to remember. The way I remember these is actually by, well, if that limit is greater than 1, that means this thing is getting bigger and bigger and bigger. So if you add up a bunch of things that are getting larger and larger, well, yeah, of course it's going to diverge. And if it's smaller than 1, it's kind of just like the geometric series. And then if it's equal to 1, we don't know. Hopefully, I don't know, hopefully you can remember that. But here, let's practice using the root test. So all you're going to do is you're going to take the nth root of n over 2n plus 3, all of that raised to the nth power. I mean, of course you're going to use the root test, because those cancel out. Now sometimes they're not always that easy, but sometimes they are. And then you evaluate that limit, just like on the ratio test. So now I'm taking the limit of something that's really nice, and going to infinity of n over 2n plus 3. That's going to be 1/2. Just because it have the same degree in the top and in the bottom. So this definitely converges absolutely. So this converges absolutely by the root test. And that's it. That's really easy. There you go. The trouble here is not actually using the root test, it's doing these crazy limits. But hopefully we have the tools to do them all. Okay.